8.3 is about everybody's favorite subject, trigonometry. And trig is really quite simple. It's really not that difficult. And again, we talked about ABC being a triangle, the sides opposite, A opposite, the side opposite, angle A is lowercase a. That all kind of comes into play here. So again, trig follows the one saying, and the one big saying is SOHCAHTOA. So, ka, toa. And what's that stand for? That stands for the three trig functions we're going to deal with. Sine, cosine, tangent. Okay, sine, cosine, and tangent. And what that means is SOHCAHTOA is saying, and this sign, the O stands for opposite. The H stands for hypotenuse. Okay, so sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. What's that mean? Well, opposite side over adjacent side. Adjacent side over hypotenuse. Opposite side over hypotenuse. So that's what that means. So if we're talking about, let's just talk angle A. The sine of A equals opposite, which is A, over hypotenuse, which is C. The cosine of A equals adjacent to A, which is B, over the hypotenuse, which is C. And the tangent of A equals the opposite, which is still lowercase a, over the adjacent, which is B. So let's look at a problem here. Writing the trig ratios, what are the sine, cosine, and tangent ratios for angle T? Again, write SOHCAHTOA up there. Okay, so we're looking at angle T. Let's do the sine of T equals opposite, which is 8, over hypotenuse, in this case, which is 17. The cosine of T equals adjacent, what's touching it, which is 15, over the hypotenuse, which is 17. And again, start by recognizing what the hypotenuse is. Tangent of T equals opposite, which is 8, over adjacent, which is 15. These are all my trig ratios. So again, using trig ratios, write it on your paper. SOHCAHTOA. All right, we're trying to solve for x. So let's identify our parts. Right there. That's my hypotenuse. What do we have in relationship to our angle? We've got the opposite, which is x, and we have adjacent, which is 150. Which one of these has opposite and adjacent? It's tangent. So I'm going to take the tangent of 5 degrees equals opposite, which is x, over adjacent, which is 150. How do I do this? Well, you kind of treat it like a proportion thing. You cross multiply. So x times 1 is x equals 150 times tangent of 5. Or you just multiply by 150 because you're dividing by 150. So tangent of 5. Punch that in your calculator, and we'll talk about that tomorrow in class. But 5 times the tangent, or 150 times the tangent of 5 is going to give me 13.12 roughly. And some decimals. What about if you're looking for an angle? Here we're looking for angle x. In both these we are. So we're looking for this angle. What do they give me? Again, write it somewhere on your paper. SOHCAHTOA. There it is on my paper. I have angle x here. What do I have? Identify your hypotenuse. So there it gives me my hypotenuse, and it gives me the side opposite the angle. So we have opposite and hypotenuse. That looks like sine to me. So the sine of x equals opposite, which is 6, over hypotenuse, which is 10. Well, now it comes in, what happens with x? Well, again, we talk about opposites all the time in math. The opposite of sine is the inverse of sine. And again, we'll talk about the calculators today, or tomorrow, I'm sorry, but the sine of -1 of both sides. Sine -1. That's the inverse of sine. That's going to cancel. That gives me x here, and in your calculator, it's inverse of sine of 6/10. Punch in your calculator. Again, we'll show you tomorrow. That's about 36.87. If you look at B, what do we have? We're looking for angle x, which is up here. Again, identify your hypotenuse. We have adjacent and we have hypotenuse. That looks like cosine. So the cosine of x equals adjacent, which is 15, over my hypotenuse, which is 20. Again, do the inverse operation. So cosine, -1, cosine, -1. Gone and gone. X equals the inverse cosine of 15 over 20. Punch in your calculator, and we'll talk about that tomorrow. You get 41.41 approximately.